Scientists are going to present design thinking on biomass conversion technologies.
Empathize. In the first stage of design thinking, we focus on empathizing with the user and the stakeholders. This skip is in the first stage of design thinking, we focus on empathizing with the user and the stakeholders. This step is very important because it is helps us to understand real world problems from the perspective of the people affected. In biomass energy project, the key stakeholders include farmers, rural households, power companies, and environmental agencies. Each of these groups has different needs and concerns that must be carefully considered. Farmers often face serious challenges in managing agricultural waste such as rices, straw, and sugarcane bases. In many cases, this waste is burned in open field, which leads to severe in air pollution and health problems. This is not only affected the environmental but also reduce soil quality. At the same time, many rural areas still struggle with access to reliable and affordable electricity. Frequent power cuts and limited infrastructure affect daily life and agricultural productivity. Therefore, we need to understand the major aspect, waste management issue, rural energy demand and environmental impact. By studying these factors closely, we can identify opportunities to create solutions that benefit everyone. Empathy helps us design systems that are not only technically effective but also socially acceptable and environmentally responsible. By understanding people needs, we aim to convert agricultural waste into useful energy while solving multiple problems at once. Thank you.
After understanding the needs of stakeholders, the next step in design thinking is to define the problem clearly. In the case of the main problem, can be stated as how can be efficiency converted agriculture waste into energy in the cost efficient and environmentally friendly way. This problem involves multiple challenges. First, collecting and transporting biomass from farms to process units can be difficult and costly. Second, traditional methods of biomass usage often have a low efficiency lead to energy loss. Another major challenge is the high initial investment required to the setup biomass conversion system, which such as biomass plants of gasifiers. This can discourage small-scale farmers or rural communities from the adopting these technologies. Additionally, there is lack of awareness among farmers about the benefits of biomass energy, and many are unaware the agriculture waste can be used valuable resources instead of being burned. In Tamil Nadu, large quantities of biomass are available throughout the year, but they are not fully utilized due to these challenges. Therefore, our goals is to develop a system and ensure efficiency, energy conservation, low operational costs, reduce environmental pollution, and over rural development. By clearly defining the problem, we create strong foundation for generating efficient and practical solution in the next stages.
Stage of decision thinking, we focus on generating creative and practical solutions to the defined problem. There are several biomass conversion technologies that can be used to convert agricultural waste into energy. One common method is direct combustion, where biomass is burned to produce heat, which can be used for cooking or electricity generation. Another important method is biomass production. Gasification is another advanced technology, where biomass is converted into a combustible gas mixture, which can be used in absence of oxygen to produce bio-oil, charcoal and gases. Using rice husk in biomass power plants and integrating multiple households share a single energy system, reducing cost and improving efficiency. This stage encourages creativity and innovation to find the best possible solutions.
The prototype stage, we move from idea to developing practical models and system design. The involves design a biomass conversion system such as biomass plant and gasifier. The design include planning how biomass will be collected, stored and proceed. For example, a village level biogas plant can be designed to collect organic waste from household and farmers. This waste is fit to design where the compared productive biomass is used. Similarly, a biomass gasifier system can be developed from small industries to generate electricity used agriculture waste like rice. During the stage, we also estimate improved factors such as installation cost, maintenance requirement, and expected energy output. We may also create small-scale models or simulation to expect the design before full implementation. The prototype stage helps use visible how the system will work in real condition and allow the identification possible improvement easily.
We test and analyze the designing system to ensure its effectiveness and facilities. Testing involves analyzing the efficiency of the energy convenience. We check that how much energy is produced from the amount of biomass, whether the system is operating efficiency. We also evaluate the cost. Production includes installation, operation and maintenance costs to help determine the whether of the system economically viable. Environmental benefits are another impact aspects. We assess how much pollution is reduced compared to traditional methods like open burning and agricultural waste. Economic evaluation includes calculating the cost per unit energy, payback period and the overall system. If the system does not perform as expected, improvements are made. For example, biomass obtaining inconsistency, better storage or supply chain management can be introduced. Testing ensures that the system realizes efficiency and sustainable real-world application. It is also in minimizing risk before large-scale implementation.
In conclusion, biomass conservation technologies offer a sustainable and efficient solution for energy generation. Through this case study, we have to see how the design thinking approach help in solving real-world problems step by step. We begin the understanding the needs of stakeholders, defining the problem clearly, generating innovative ideas and developing practical prototypes and the final testing and improving the system. The systematic approaches ensure that the solution is not only technical, sound but also economically valuable and socially acceptable. By converting agriculture waste into energy, we can reduce the pollution, improves waste management and provides renewable energy by rural areas. To also support farmers by giving value to agriculture, reduces that would otherwise be waste. In future, adopting such a sustainable technologies will be essential to meeting energy demands while protecting the environment.